Good afternoon, everybody. Today we will discuss the chapter chromatography. Chromatography is a very important chapter in lab or in also organic chemistry because we can separate the mixture of the component using the chromatography. Chromatography is the laboratory technique used to separate out the mixture into separate out the compound in the different constituent. Now, chromatography is depends on the two phases. The number one phase is the stationary phase. Second is the mobile phase. Stationary phase is a fixed state and it is act as an absorbent. And mobile phase is nothing but the carrier phase, which means when we make the mixture of the solvent or we separate out the mixture of the solvent, we can dissolve the mixtures in mobile phase and then run in a column to separate out the mixture. The stationary phase is fixed in the column. It is fixed in the column and generally it acts as an absorbent, and mobile phase is a carrier. On the basis of these mixtures, we can dissolve in mobile phase and run on this column and we can evaluate the separate component at this point. Now the mixture is separate out. The basic principle is that affinity between the stationary phase and mobile phase. It means that when mixtures contain A and B compound, A and B component, at that time, if the affinity of the A is with the stationary phase absorbent, at that time B is evaluated first and later on A. That means if mobile phase affinity between the B is more than A, at that time B is evaluated or come out first B component. Now the column chromatography is totally depends on the stationary phase and mobile phase. Now depending on the types of mixture, we can chromatography also in 6 types of the chromatography. Now the 6 chromatography is first is the gas chromatography. Gas chromatography is the very essential chromatography in organic chemistry or pharmaceutical chemistry. Generally, this gas chromatography used when the compound is volatile in nature. That is, the compound is easily evaporated. At that time, gas chromatography is very useful technique for separate out the volatile compound. Now, in this case, the mobile phase is generally use gas molecules. In this case, the mobile phase is use the gas molecules, which are the inert in nature, like that helium and nitrogen gas are generally used in gas chromatography. And in stationary phase we know that this is act as a fixed phase and act as an absorbent. And the mobile phase stationary phase is a polymer or activated charcoal. Polymer material and activated charcoal are used as a stationary phase in a gas chromatography. Sometimes liquid also used in act as a stationary phase, which is coated on the inner wall of the column, which is supported by the solid material. Now, these gas chromatography are very essential for volatile compound. Means chromatography is having the six type. One is like the gas chromatography. Gas chromatography used when the compound is volatile in nature. Okay. Now second chromatography is liquid chromatography. Liquid chromatography. This liquid chromatography used to separate out the liquid mixtures. The liquid mixtures are easily separated out in the liquid chromatography techniques. Now the mobile phase in this case are liquid, that is water, methanol. These are the polar in nature. Non-polar in nature is hexane, toluene. These are the non-polar in nature. Sometimes mixtures of the solvents are used. That is hexane plus acetone. Because this is the polar in nature, water and methanol. This is non-polar in nature, hexane and toluene, and these are the intermediate between because hexane is non-polar in nature and acetone is polar in nature. So these are the intermediate in polar and non-polar. These are the non-polar solvent mixtures, or these are the polar in nature. Now the chromatography, liquid chromatography, in this case stationary phase. Stationary phase is generally the silica. Now in this case stationary phase is silica gel. These are the polar in nature, and non-polar in nature is octadecasiline. Now the mobile phase and stationary phase choice depends on the polar and non-polar. When mixture is inserted in a column, at that time what happens? Stationary phase is polar and mobile phase is non-polar in nature. Or when stationary phase is non-polar in nature, at that time the mobile phase is a polar in nature. This polar and non-polar between the mobile phase and stationary phase, which are the responsible for separate out the liquid component mixtures. What? These polar and non-polar are natures important in the liquid chromatography to separate out the component of the mixtures. Okay. Now third. Now the third chromatography is a thin layer chromatography. Thin layer chromatography. This in short we can say TLC. Now this TLC or thin layer chromatography is a cost effective, fast and time very fast technique used in the BSc chemistry lab also. Why use this TLC? Because the completion of the reaction or monitoring of the reactions, we can easily identify the thin layer chromatography. Now by example we can say that suppose A plus B gives products C, P for product. Now suppose A and B gives C, at that time using TLC. Now in TLC mobile phase and stationary phase also help for the monitoring of the reaction. In this case the mobile phase are the liquid. Here also mobile phase are also like water, methanol, acetonitrile, and stationary phase is silica gel or alumina. In the column silica gels also used, and in PLC also we use the silica gel, but these are the flat three-dimensional plate. In this plate, uniformly distributed silica gels layers are formed. When we can prepare it, silica gels, at that time we can dry for some time. After some time, we can use the PLC plate. And this silica gels having the porous part, which can easily run the solvent in upward directions. So when we can spot at the bottom of the PLC plate ABC spot like that here is the PLC plate, and now A, B, P for product, A for reactant 1, B for reactant 2. Here the small spot noted here, dotted at the bottom of the PLC plate, where we can plate this PLC plate in a here. At that time the solvent is run upward direction. Why solvent is run upward direction? Because the capillary reactions. Because silica gels have a porous part, at that time they are the force to exert to hold the liquid in upward directions, which are the anti-gravitational force applied here. So the solvent runs in upward direction. At that time the spot of the A, B, C also runs with the mobile phase. Mobile phase is a maybe water, methanol or acetonitrile. At that time we can see that sometimes the spot of the A, B or C may be stopped and solvents move to upward direction to some here. Here the solvent ability to move upward direction is stopped. Now we can easily identify if the completion of the reaction is take place at that time. The spot of the or color of the reactants observe here. Color of the spot observe here. If A is a color A is color here, B color is here, and C color is here. They are different. At that time we can say that the reaction is completed. If the compound is not visible, at that time we can use UV chamber, iodine vapor to visualize this spot. At that time we can determine the completion of the reactions or monitoring the whole reactions. Now in this case, most important part is here that RF value. RF value is what is RF value? If this A spot or B spots run up to here point, at that time the distance between this point to this point, or this point to this point, or this point to this point are measured in RF value in centimeter, and the solvent distance is here from this. At that time we can say that RF value is distance traveled by solvent, distance traveled by compound A or compound divided by distance traveled by solvent front. Front means what? Because solvents is ability to move here. This is the bottom end of the upper side of the solvents. Now this RF value is determine the types of compound or identify using the standard value of RF value. We can say that A, B, which are the compounds. A, B, which we can identify the A and B. Now RF value is generally between the 0 to 1 always. because the solvent's value is greater than the solvent value is greater than the component value. So the other value is the 0 between the 0 to 0 to 1. Now fourth chromatography is a paper chromatography. Paper chromatography is also inexpensive method, expensive, very fast and cost effective method used in the TS chromatography. Now the paper chromatography, the mobile phase is also is here the liquid and stationary phase is the filter paper or cellulose material. Cellulose material or filter paper. Mobile phase is a liquid. Like TFC, paper chromatography also work on the capillary reactions, and paper chromatography is generally used in the color compound like ink, green pigment, various color substances are separated out in the paper chromatography. These techniques for used for the color compound only. And like that TSC, paper chromatography also work same RF value are also calculated in the paper chromatography. Now the flip chromatography is such flip chromatography is ion exchange chromatography. The name suggests that ion exchange. In this chromatography, mobile phase is buffer solutions and stationary phase is a polymer like agarose, septodrops are used in the ion exchange chromatography. Cation exchangers materials bind the negative charge molecules and anion exchange bind the positive charge molecules, and this principle opposite each other like charges attract each other. Using this principle we can separate out the mixtures of the component, that is cation exchangers separate out the negative charge particles which absorb out the negative charge particles, and in cation exchange material, that is stationary phase, if you use and this anion exchange material, at that time positive charge molecules are held by the stationary phase. Using this principle we can separate out the mixtures of the component. Also in this case the mobile phase are used as a buffer solutions. Mobile phase are used buffer solution. Since the pH value does not change, even the small amount of concentration change, and if the concentration changes, at that time what happens, the ability of holding the negative or positive charge in the stationary phase also disturbed. So the important is that buffer solutions are used as a mobile phase to separate out the ion exchange chromatography. This ion exchange chromatography generally used in the protein, polypeptide, amino acids separation, because there are various types of ions are present in the various types of ions are present in the chromatography. Now the sixth chromatography is a size exclusion chromatography. Size exclusion chromatography. This name suggests that the chromatography is basic principle is that size. Depending on the size, the chromatography is work in the size exclusion chromatography. The stationary phase are the porous bed. Having the small holes in the porous bed, large molecules are not trapped by this porous bed, so that in column, when the material of the porous bed is here, at that time what happen? Large molecules are evaluated first, and the small molecules are trapped in the porous bed, so they take more time to evaluate in the column. Now these methods is depends on the size only. Here the mobile phase is not important in this size exclusion chromatography. This is a very rough method used in chromatography according to the size only. Now we have covered the 6 types of chromatography. Now I am thankful for the students which is helpful for your study. Thank you.